This is a PetG material, and as you know, PetG strings like crazy. So what I'm doing here is a temperature tower to identify at which temperature the stringing is less. So what I've been doing here is manual. I did not do it from the G code. What I did is I came in here and go to tune and go to nozzle and basically tweak this up and down as per the level. So every time a new level being started, every time a horizontal line is finished and is starting on a new one, I just tweaked it down by 5 degrees Celsius. And the goal of that is to identify which temperature has the least amount of stringing. PetG is a great material to print with and has a very nice appearance and generally very printer friendly. But the only problem of it is that it strings like crazy. So you can find a link to download your own STL file to print your own temperature tower, so check it out in the link description. A couple of layers later, we might have found a sweet spot, and that sweet spot I'm thinking between 220 and 215. As you can see, for these 220 and 215 is significantly less like stringy mess, alright? But I am noticing something as well. As you can see, when I zoom in on macro, there is a little bit more appearance of the lines on 215 as opposed to, let's say, even a 220. So right now I'm kind of like thinking that 220 could be the best one, but in the overall, having a temperature tower test to calibrate your printing temperature is really good, because a lot of people will say that, oh, PetG, you gotta print at 240, you gotta print at 245, but look what that got even at 240. And the same thing is, you know, before this I had to change the PTFE resin tubing on my printer because it was too hot, that the head of the PTFE actually melted, and it created, you know, a whole amount of gunk and mess and a huge inconvenience, and I was unable to print for a week before the replacements came in. So if you haven't already done a temperature tower, I highly encourage you to do so that you can experience higher print quality and also electricity savings and better prints. I already said better prints, electricity savings. One more thing to consider though is that, can we do a similar test for build plate adhesion for different temperatures? I think that will be pretty good as well. So I'm currently printing at 70. I want to find out how low I can go but still maintain a good adhesion, because yesterday I did print a character, and when it was 70% done, you know, it just came off the bottom, and that's because I reduced it down to 50. Okay, this is now coming down to the final layer. This is at 180 degrees, and this is PetG. So we had several different textures. I'll be studying this in detail in a moment, but as you can see, this is also the last temperature which any successful print can be given. In fact, it's not even successful, it's highly distorted. So we will be having a look in detail in a moment. Okay, now let's have a final analysis of this temperature tower, and this again shows the differences in different temperature. And obviously, the couple of things I look out for, I'll point it out to you. Like number one, I'm looking at like how well the layers are sticking. So I'm looking at on the right side, like how close and smooth these lines look. And actually, on this side, you cannot see much of a difference, but it gets a little bit more obvious when we go into the numberings. I find that there seems to be like a sweet spot at this, you know, maybe 200 to 215 range, because above that, there's a little bit of distortion in how the numbers appear. So a little bit distortion. So the next thing that I want to look at is that on these layers that go across, because in the printing process you can see how it literally goes one end to the other, and I want to look just beneath that, beneath all these levels. So if you're able to follow that, you can see how there's some dots appearing here beneath the 210, and it actually gets worse and actually gets a bit more stringy as we go up. As you hold it against the light, you can see it gets more stringy, and that's because on the base it's almost as though the lines are not even bonding. Okay, on the top, yes, it's bonding quite well, but on the bottom, not the case. So this would lead me to think And you can also look at the back end of it. So this is a really, really good test. In the back end, it shows like the extrusion. If I look into the smoothness of the base, I think it has to be around the 220, 215. As I look on the reverse side, as you can see, because like 210 and above, it just gets really, really messy on the bottom. I mean, the top still looks fine, but the bottom is just a mess. So I conclude that for this particular filament, this PetG filament, on my printer, this is the Ender 3. The best would be the 220. That's the champion. Have fun trying out your own experiment of calibrating with this temperature tower on your printer, and let me know in the comments what is the best one for you.